Let's get started then. Software maintenance. What a boring topic, right? So to make it a little more challenging for you, we put this talk directly after lunch. So you have a little bit of a fight here. So, of course, it's not boring. And of course, it's also not really about maintenance. We want to talk today about stay current by actually reducing the amount of maintenance you have by doing this, by automating these things. And to stay current, to actually unleash all the power which comes with it, right? You have, from my point of view, a very high motivation factor when you have developers coming from a conference and learning what all new stuff is there, and then they're coming home to their application, which only runs Java 8, and far away from Spring Boot 4, maybe not even Spring Boot yet. So that's a high motivation factor. Another one is, of course, in the performance, the power you get out of it. Java 21 is so much more powerful than Java 8. The newest version of Spring Boot, they have done a lot to increase the performance as well. And of course, the stability. If you monitor a Java 21 application, you get so much more data out there. You get a lot of metrics and traces and everything out there. So that's what we want to talk about. So welcome to our talk. My name is Joachim Pasquali. I have with me Afsana Raman, and we want to show you today a little bit from our journey, but mainly the tool set we are using for that, to automate the stuff, to how do we actually approach this topic. So let's dive directly into it with a mandatory 30-second pause so that you can read this. 30. Okay. The increasing pressure to stay current, right? I mean, there was always and there will always be the pressure. The customer always wants to have new features, and as a developer, you're kind of feeling like you're running towards a moving finish line. It always kind of gets a little bit forward, and there's always the new feature, there's the vulnerabilities, there's code coverage, there's all that stuff. The security part actually got increased in the last couple of years. We are kind of requested to go to production immediately after the fix goes out, and all of you know how hard that can be. Another one is when I'm dealing with a microservice architecture, I want to get my framework out. I want to get all my microservice current. And compared to a monolith, of course, you don't have one deployment. You have tens, hundreds, or even thousands of deployments. And you want to get that out as fast as possible. What we will not cover today, but which is definitely a prerequisite, and that's why I want to mention that, is that you have to have the SDLC in place to actually go to production. So if you change your code, or in our way when we have the code changed by automation, you still need to go through the test cycle, of course, have the high quality data, code coverage. So you should never have a fear to go to production, right? So our journey, when we started this microservice a long time ago, we already were aware of the fact that instead of one deployment unit, we have a lot of these things. We have it very distributed. There is a complexity we have to take into consideration. And when I give a developer a tool, a feature to develop, I don't ask him just to develop that feature. I ask him to develop the feature, take care of security, take care of the logging, take care of the metrics, take care of code coverage, so many things. And there's a lot where we can support the developer, where we can actually make the whole process so much more efficient. The first approach we took the Spring initializer, we forked it, and we kind of modified it that when you press the generate button, you not only get a Spring Boot project, which is a good start, but we also wanted to get our governance in there, right? So we added some properties by default. We added some libraries by default. Some common libraries which did auto configuration so that we took care of security automatically and all the things. We also generated variable files, which we kind of hooked into our generic Concourse pipeline at this point of time. So after 10 minutes, the developer was actually able to deploy the service to our test environment using a pipeline. Next step, we then we introduced a parent POM. We wanted to define some guidelines centrally, so we plugged in our Jacoco plugin there, then we defined PMD and check style, code formatting. Might sound very similar for you. And we also solved our vulnerabilities there, so versioning update, and then we pushed out the POM file. It was working well, but it also has some limitations. The Spring Initializer specifically, the Spring team does a great job to update this frequently, constantly, I would nearly say. And so you also have to upgrade your special Spring Initializer very often. We needed a couple of people who knew exactly how the Spring Initializer works. So there was a pretty high maintenance effort just for this initializer. And when your department goes into microservices, you're creating a lot of microservices, but at one point of time, you probably stop doing this. There's not the need every day to create a new microservice. So there was a huge maintenance effort, and I just really needed that very rare at one point of time. And it gave me a very good head start for the developer, but it did not support the developer during the maintenance phase. Right? He still had to upgrade the version numbers afterwards manually. The parent POM was and still is a pretty successful process we have, I would say, but it also has limitations. It addresses the problems in the POM file, but it does not really support me when I want to have a Docker file, or I want to have a GitHub action pipeline, or something outside of the POM XML. It was also a little bit of inflexible when I had microservices which are more supporting batch and some are more online and had a little bit of variations. You could not really support that well with the POM file, with the parent POM. It doesn't work with Spring Advisor, so it's called App Advisor. For me, an app is automatically Spring, so I always mix that up, so you can take this as a synonym. That was actually for us the big blocker at first to not go with this App Advisor, which is one of the tools we want to present today. But we had to find a way to go around our parent POM, our beloved parent POM, actually. So I want to kind of stress one topic, and that is that I want to not just stay current in my application. I also want to give the developer more headroom. If I ask him for so many things, what of these things can I take away from him to increase the efficiency? That is one part as well. So we are concentrating on 3 tools which we are using to update our application automatically. As we had to get rid of the parent POM, we had to find something which allows us to inject every single microservice with exactly the same guidelines and plugins and everything we had. So Deshaun from Broadcom wrote a nice project which he himself called Initializer++. And I would recommend really to take a look at this. It's a very small and simple CLI tool based on Spring Shell. Spring Shell is a very easy framework for you to create your own CLI, command line prompt. I would even say within half an hour you have your first CLI written. It's just based off very simple annotations, and the shell command does its own. He also added native compilation, so you can nicely put it on your local machine. We also run it in our pipelines. And this tool is mainly taking care of everything we want to initialize after the Spring Initializer is done. We want to add our plugins, we want to add some other kind of things, we want to add a Docker file, we want to add a pipeline. This tool does that. Much less maintenance effort than the initializer because it's so much more simple. And the fact that it also runs in the pipeline, we not just use it for the initialization of a project, we also use that intensively then in the maintenance phase. When we have a new version, we actually maintain the versions in a database. And then the command line tool just gets a new version, updates it, makes a pull request, and the application owner just get a pull request and then which is also very helpful if you have a microservice which is not under heavy development anymore. It's kind of laying around, but you still have to keep it up to date. Vulnerabilities want to be fixed, right? Okay, the second tool we want to present today and demo today is Open Rewrite. Not really intensively, but Open Rewrite is a tool which allows you actually to change your code in a very deterministic way. So we actually put our guidelines in there. So when you kind of look at how we treat our developers, we give them tools in the hand which actually tells the developer constantly that he's not yet done with his work, right? I give him SonarQube, and so he runs it, and then SonarQube says, hey, you have 5 code smells. Please go back. And then I give him a security scanner, and he tells him, hey, you have 3 vulnerabilities. Please fix that. So, and he has already a hard, long day, and then he gets all these things and he has to go back. And we say, no problem, the day has 24 hours and there's still the weekend, right? And this here is actually doing the work for him or for us, right? It is allowing you to define your own rules. So you can see here, for example, it can add the finalize keyword. If that's part of your check style or PMD, it can remove unused imports and a lot of other stuff. So we might take a look at this URL as well. There are about 4,000 recipes out there, which you can then group on your own. You can just use them on your own, or you can kind of customize them or composite them. So I brought that under the do not bother the developer so that he kind of can get home maybe in time. And then the Spring Advisor / App Advisor. A tool which you get when you have the Spring Enterprise license. And one of the main advantages of that is, first of all, what does it? It upgrades your application to the next Spring Boot version. And it does that also using Open Rewrite in the backend. And so it does all the needed changes. If they have properties which are getting deprecated, if their methods getting removed, or some classes getting repackaged, the Spring team knows that, of course, because they did the refactoring, and they're writing the recipes for us. So I just run them. And I really love that, because this maintenance effort is really nearly zero. Once you've figured out how to run this in your company, some smaller companies might not have an issue with that at all. In bigger companies, there's always a little bit of bureaucratic overhead to get the Broadcom repository included and so on. But we want to demo that as well today. And it supports also step-by-step updates. That means if you're really kind of a little bit behind on 2. something of Spring Boot, some had issues, or some departments have issues maybe to upgrade to Java 17. They do this step-by-step as well. You always get a diff, and then you can validate, and then you can go to the next step, and so on. Okay. I think we talked enough. So now imagine what we want to do. Maybe we switch first the monitor there, and then kind of demonstrate a little bit how the experience for a developer looks like when he has created a new microservice. So Asana, please go ahead.
Okay. So can everyone hear me okay? Okay. Hello, everyone. So as we went over, we have 3 tools that we have implemented. So for the demo, we're going to start with the CLI and what it does. So what I have pulled up here is a Spring Boot project. Nothing too fancy. It's just 3 classes or so. I think 3 classes, and they're pretty small. Nothing major. And what we want to do is fit this to our team standards. So let's say I was given some business requirements, write this microservice, and then I wrote the microservice. The code is done. I did a good job, because I always do a good job, right? Yeah. Awesome, okay. So we have a working project, but now I bring this to Joachim, and he's saying, okay, is this ready to deploy to our Kubernetes cluster? Is this ready to work in our GitHub pipeline? Is this ready to do this, that, and the other? And then I have to go through and I have to sift through hours of documentation that's probably out of date, and I contemplate all my life decisions. So instead of doing this, what we can do is we can use this FLI tool. So I type FLI enter, and opens up this interactive shell that we've created ourselves. It's custom to our business needs. So I'll type this help command so we can see all these different commands that we've written. Quite a few. So we have quite a few requirements. These pertain to our pom.xml, what plugins we want to add in, workflows, Dockerfile, etc. So you don't have to open up the interactive shell if you know what you want to do. You can just do FLI. In this case, I want to do this init all command, tr init all, and press enter. We're going to look at these changes here. So we can see that a couple files were added. So we have our workflow files according to our team standards. So we don't have to worry about, I don't have to worry about if this is going to run in the pipeline, perform the steps that we need it to. It's already there. We have our Docker file that's also set to our team standards, custom for our golden image. So that's done. And then most importantly, we have the pom.xml. So if you see in this git difference here, let's see, can I make this bigger? How do I make this bigger? How do I make this bigger?
So you can and just remove this a little bit down, and then you can.
Ah, okay. Thank you. So as you can see, there's a bunch of different dependency management that's added here and all of these plugins. So as Joachim was talking about, there's a lot of bureaucratic overhead that goes into creating applications, getting plugins to work within the Fiserv ecosystem. So instead of the developer having to spend hours figuring out how to work around these blockers, it's already done. CLI did it for them. So next question is, we have these version numbers that are basically just in there. So where do they come from? And more importantly, these tend to update pretty often. So how do we keep this up to date when there's new fixes that come out, different libraries that get quarantined, et cetera? So what we have is this UI. So in the project here, we have this dependency Azure SDK BOM. So I'll pull that up in the UI. So we have the artifact name and the version number. So what we can do in this UI is we can actually edit the version number. I'm just going to make it a little higher, save it, and then I'm going to run the same exact command. So the developer doesn't have to know that this happened. If they just run the command again, which should happen, yay, it worked. So now it's 1.2.37. So because this UI is deployed to our cluster, because it's deployed there, it's centrally managed, so the developer never has to worry about these versions ever again. I don't know if you have the comment about running this in our pipeline.
Yeah. So one of the things we want to do as well is, right, we want to find an automated way to get the newest version of an Azure. You don't want to look at it manually all the time. What is the newest version of Azure SDK BOM? Is there something new out? Is there a vulnerability? You should not even take care of that. You can, of course, then have a small script which looks up the newest versions out there. And if there are new ones, you just push them into the centralized database. As well, if you write your own libraries, just add another small step in the build pipeline to push a new version into this database. So the developer now has a CLI on his command line. If he runs it the next time, it will update, but he doesn't even need to do this because the batch runs anyhow, the pipeline runs anyhow every night and checks if there's something to update. So the application owner should actually just get a pull request. And as I said, you still need to test that, right?
Thank you.
Can you switch back the version number? Otherwise you cannot build
yes,
it.
thank you. So what we want to do is now I want to run a Maven clean install on this project. So let me just change this back. Save, and then I'll run the command line interface again, please. So this should change back to 1.2.36, lovely. So now I'm going to run a Maven clean install on the project and just pay attention to the changes on the left-hand side. So we'll see a couple files get added. So the plugins that we added with the CLI, it's going to run a few extra steps for us. So we have these PMD checks, we have these check style checks, and now you see this rewrite plugin that's coming up here. So waiting for these changes to come through. Did you write test cases for this?
You can run it without the test case.
Okay, so it worked. So now you see on the side, we have a few changes. So we have these final keywords in the code. So that makes it a little more efficient. We also have
Service, take the service.
the service.
Yeah.
Yeah. So in the service, we took out this extra line that was not needed, adding the final keywords where necessary, adding this dot modifier where it's needed. So again, these are things that before the developer would have to go through manually. When it runs the check style PMD plugins, it would just give us a list. Actually, let me demonstrate this. If I comment out this Open Rewrite plugin, let's see, Open Rewrite, get rid of this, goodbye, and then I'll revert these changes. Roll back, please. Okay, we're doing it one by one. Sorry. I just write the code, I don't do this stuff. Okay. Okay, so now we're gonna do a Maven clean install again. And not only will the build fail, but we'll see that list of issues that we were having. The thing that the Open Rewrite handled on its own now suddenly becomes issues that the developer has to handle. So we see this build failure, and look how ugly this is. It's barely readable. So now the developer has to read through this, find where the error is, and then fix it themselves. So with the Open Rewrite, we immediately had a build success because the plugin just handled all of those changes for us according to our team standards. Mm-hmm. So Joachim, if you want to go more in detail about Open Rewrite.
Yeah, so Open Rewrite, as you have seen, has done some code changes for us. And what I like at this is actually you put in the plugin. If you want, you can just add the dependencies of Open Rewrite into this plugin and then just list out which recipes you want to execute. So there's no code you have to write, there's nothing. I also want to show very quickly how that looks like. So they have a bunch of recipes out there. And if you look at the statistic analyzer, for example, I just scroll down, but you see there's a lot of things which they already have. And you can also select off what they call the composite recipes. So they have kind of a bunch of recipes where they say, oh, this is best practice, let's do that. So you just have to call one recipe. Or you just choose and pick which recipes you want to actually execute. They always have a small example before and after. What are the changes? So it's pretty nice. It works for what we use it right now for kind of constantly ensuring our guidelines without bothering the developer. But it also is very useful if you have the application in a very old version, Java 8, you want to go to Java 21. They have an excellent support for that as well. Of course, if you have, for example, a switch case block, and you write it in Java 8, it will run in Java 21. There's no question. Java will always be backward compatible. But the new syntax of switch case is just more readable. You just can create a project which is better maintainable. And why not do it if it's for free, if you can just call it, right? So the second option is I can create my own jar file. And in my own jar file, I can just write a YAML file. And a YAML file where I just put together the recipes I want to execute. So you can see here the finalized blocks, and I remove my unused import, and then I have the this modifier to a method call. So if I just write the YAML file, I still have no code to maintain. It's still very low maintenance. In that case, just to show an example, I have actually created this one class. So Open Rewrite allows you, of course, to write your own recipes, and a lot of companies do that already. We just started to dive into that. I have to say there is some skill set you have to learn. And when I talked to Deshaun Carter from Broadcom, he said, most probably you will have in a company just a handful of people who do that. There's no need to really have in every department people who are familiar with that. These things really need to be tested well. It's not simple, I would say. But how it works in general is they compile this to a lossless semantic tree. They give you a in Java at least, a class called J, and then you can iterate through the tree and you can search and change the code. They also have what they call the Java template builder. So you say, I need one import, and if the import is already there, they don't add it a second time. So there's some support and help in that as well. And then I need this method, or I want to have this pattern. If this is before, that is a pattern after. They have some test support. But these topics can be very complex. For example, this, to add the this modifier, you need to know if the class or the method exists in your class or in the parent class. So you need to iterate through different compilation units. So it's not that trivial. I would say that in 90+% of the cases, you're good without any writing your own code. But I heard also from other companies that they actually embrace that. I think Elite is one of the companies who does quite a bit of that. Okay. The next one is the App Advisor.
Okay, so I am going to log into our environment, so no password for show. So please bear with me. Could we put the Jeopardy theme? That would be helpful. Do 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 do. Do, 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 do.
Are you ready?
Yes.
Okay.
Okay. So now we have a test project. There we go. Our test project. So this one's a little different than the project that we just showed. I made it a lot worse. So I'll show you the pom.xml for this. And this project is currently running on Spring Boot version 2.7, which is terrible, no good, very bad, disgusting, heinous. Any negative word that under the sun is what this version is. So what we want to do is we want to update it to make it nice and shiny. So first, just as a safe check, I'm going to prove to you that this project somehow miraculously still builds on Spring Boot version 2.7. It's a little slower when it's up here. Okay, so now we're building just fine. So with the App Advisor, all you need to do is just know one simple command. So the advisor, and we have this upgrade plan, and I'm going to do a get here. So what this will do is first, you'll see this step that says build configuration file does not exist. So what this file is a file that the App Advisor uses that contains things like metadata for the project. So things like information on the GitHub repository, information on what tools the project is using, such as the Maven version, the Java version, that kind of thing. The dependency tree is in that file. So the dependencies that the project is injecting directly, as well as the dependencies that those dependencies are pulling. So it puts all of that in one file. And then what the advisor can do with this is it can create this upgrade plan, which just came up here. So as Joachim mentioned, it breaks it down into steps, so you have more control over the upgrade process. So now when I do this upgrade plan apply, what this is going to do, it's only going to run this first step here. And within this step, we see this upgrade Spring Boot from 2.7 to 3.0 and upgrade Spring Framework from 5.3 to 6.0. So again, like Joachim mentioned, these are the recipes that the advisor uses, very similar to the open rewrite recipes. So it's a subset of libraries that the advisor looks into, and it's able to pick them out for you. So instead of the developer having to go in and change the version and then see what breaks, now the advisor knows exactly what to do and knows what changes to make, and it can make changes to the source code on its own. So it's going to do this locally. And then once it's done building, I can show you the different changes. So it'll go into your app properties. It will go into your source code. It'll change annotations. It'll change imports. It'll remove unused dependencies, all of the above. So there's doing it locally. And then also what I will show you later is also you can do this push flag. So you can interact with the remote repository as well. You can create a pull request with these changes instead of just having it locally. So it's still upgrading these sources. It's running these two recipes. So like I mentioned, we're only running the step one. So the Spring Boot 2.7 to 3.0 and Spring Framework 5.3 to 6.0. I also don't know if I mentioned, but the advisor only supports up to Java 17. So if you also want to do Java upgrades, the advisor supports that as well. So those will usually be the first steps, but I went ahead and did that already. Otherwise, I would have had to do a bunch of SDK, blah, blah, blah. And I didn't feel like doing that. So allowing it to upgrade still. It only took 30 seconds when I was doing it locally, so I'm not sure what's going on there. I do have the changes on a remote repository already. I created a failsafe just in case. I'll have this on the side. So that is here. So I'll show the same changes. But basically, like I mentioned, it'll upgrade the Spring Boot version. So it's actually going to update to the latest version of whatever that major version, or sorry, the minor version is. So it's 3.0.20. So it updates this, it updates these. It's not formatted very well because it's small. There we go. So it removes these unused dependencies. Like I said, it updated this Tomcat embed core version. It changes these annotations. It updates JavaX to Jakarta as well, so that's a pretty major one. This can be quite intensive, especially for microservices that say are like this particular service is maybe 30, 40 lines of code. I personally, on my team, the team that I work on, we had to deal with the microservice, I believe it was like 3,000 something lines of code, and it wasn't just like cute little import lines of code. It was very intensive, very logic heavy kind of thing. So the advisor is able to handle all of this just fine. And then also it changes these properties. So you have this little comment from the app advisor actually, which adds this property, which originally was implicit in the 2.7 version, but is no longer implicit in 3.0 and above. Oh, sorry, this is the meta-inf file. This is the app properties. Yes, let's see. I successfully applied the upgrade, so I will show you exactly what I just showed you here. So the dependencies, the removed dependency, the annotation differences. Oh, I didn't explain this. So in Spring Boot 2.7, it's implicitly expected that this will, if a user makes a request to this endpoint, they can have the trailing slash or not. It'll accept both. In Spring Boot 3.0 and above, you have to explicitly state that. So I made those changes to all of these annotations here. Et cetera, et cetera. I already showed all of these. And now we're all good. So I'm a little, so all you have to do to upgrade with those next steps is just keep running this upgrade plan apply. In this case, I'm going to do the push, and that'll create the pull request. And that is also going to take probably just about as much time. So it's cool to do the pull request locally, but what's significant about doing having that push flag feature is that now we can inject this to our pipeline. Ignore the workflow name if you saw that. So we have the step here. So in this build step in our workflow, let's see, let me make this a little bigger. The cursor is like reverse. I'm not used to that. There we go. Okay. Yeah. So we get the tar file from our remote from our Nexus. We untar it, and then we do this upgrade plan apply push, and then it needs a Git token, but we have the Git token within our workflow environment. So it runs this job. Then I can show you the PR as well. So that is here. So you can see that this is not me. You'll see that when the command that I just ran in the terminal, when that comes through, that'll be under my name because it's my personal token that I use for that. This is our Fiserv workflow user. And then when it made this pull request and made these changes to the pom.xml, in this case, it changed the build step was from Spring Boot 3.3 to 3.4. So it's the same thing that we saw before, where it updates the versions. And the developer doesn't really have to worry about this. The dev just has to check in periodically on their project every now and then, see if this user raised a pull request. And then if they raise the pull request, look it over, make sure it builds, so the tests are running fine. Again, the build and test, you can also inject into your pipeline. And then approve the pull request and your project is kept up to date. So it goes into the overarching theme of, the developer should feel secure in their applications, and that when they do upgrades like this, there's more of a fail-safe. They don't have to put as much time into their maintenance effort. It's a little more, robust, that kind of idea. So let's see. This is probably going to take a while.
Okay, I think we have shown what we wanted to show.
Yeah.
Before we leave you with some final words, are there any questions?
So I see that you're doing this one repo at a time. Is there a plan to do it by batch?
Yeah. So the question was, we are doing this with one repo at a time. So we will have we have a nightly run which kind of runs that for every single repo. So if you're creating your microservice, you get a pipeline automatically using our CLI tool, which then creates also the scheduled pipeline, which does the work for you in that sense, right? So a couple of updates we are planning to. Right now, the FLI tool does not need to be updated. It always gets the updated versions. But what if we actually create a new feature in the FLI? So things we want to actually add is that the developer gets automatically informed that there's a new version of the CLI tool available, and maybe just download it with a link. So kind of more convenience features we want to add there. And what I also like in the FLI tool is that if you want to add, let's say, Cosmos database support, right? And we already have some Key Vault support, and we already have some predefined environment variables. Why should the developer look that up? Just put this in the CLI and it will kind of take care of the properties and of the dependencies you want to add. And still there will be some guidelines out there, but he should not necessarily, or she should not necessarily read all of that. So, any other questions?
Oh, yeah, we got the pull request.
We got the pull request.
Yeah, so you can see it's under my name because it was my token, and we have the changes here. So this is going to include the changes from the 2.7 upgrade. So now it's upgraded to 3.1.17.1. I don't know if I've ever seen spring parent version with 4 of those.
Yeah.
But yeah, it's all the changes that we mentioned. Typically, this merged all the changes from the 2.7 to 3.1. And this other PR, what you can also do, or at least what I demonstrated, is you can do commit by version. So I have this upgrade to Java 11 that the advisor did, then I upgraded to 17, then I did 2.7 to 3.0, then I did 3.0 to 3.1, and I did a Maven clean install, ran the tests in between to make sure that it worked. So this would be the optimal situation for if you have an older project that you just kind of need to do a one and done upgrade for.
Okay, so to conclude, just want to mention that again, it's not just about fixing vulnerabilities, it's really about efficiency, I think. It's about motivation, and it's about performance, right? So, thank you very much.